Right on time and right on schedule. I am going to introduce our first presenter, Grace Kwan, who is with orca.so, and she's going to be telling us about Solana, a scalable cryptocurrency technology. And one of the things that I love about the ScaleX event is learning about stuff that I've never heard of before. So my first introduction to Solana is through this event. And Grace, thank you for joining us today from Tokyo, and we appreciate your time. And I'm going to turn things over to you.
Gary, thanks so much for the intro. And yes, I imagine this will be many of your first time hearing about Solana, so hopefully it'll be pretty interesting. Let me just go ahead and screen share here. That look good? All right, perfect. So again, today I'm going to be talking about Solana, which is a super scalable blockchain, and in turn enables building apps that were quite unprecedented on former blockchains, which I'll get into in just a second. A little bit first, though, about why I'm qualified to even talk about this topic. So again, I'm Grace Kwan. I'm the co-founder of Orca, a user-friendly decentralized exchange on Solana, which I'll explain a little bit in the next slide since that's pretty jargony. I also go by Ori within the Orca community, just in case any of you happen to already be using Solana. I'm also previously an interaction designer at IDEO Tokyo, as well as a software engineer at several startups, including Coursera, and have a background in computer science at Stanford. So kind of all over the place. I'm also a bit of a hobbyist illustrator, so you'll see some illustrations in the slide to help explain some of these thorny technical concepts. I've kept them kind of cute and light, so hopefully that helps things be a little bit more understandable. So a bit about Orca before we dive on. Again, it's an automated market maker style decentralized exchange on Solana, which means that it can power transaction volumes, which are quite unprecedented before on Ethereum applications. We've only been live for 2 months, but we already have over 50 million US dollars in total value locked in the system, as well as over $5 million in daily exchange volume. So things are pretty exciting here. But what I'm actually personally really proud of with Orca is that we've aimed it to be a super approachable and user-friendly trading experience, which is largely due to the super performant nature of the Solana blockchain, which allows even a decentralized finance application like ours to have performance and an experience which feels more in line with that of a traditional fintech application. And the whole topic of the talk today is exactly how that happens on a technical level. So again, none of this might have made sense to you if you have no background in crypto or finance. Totally fine. The core concepts will hopefully still make sense. But if you are curious, feel free to visit us at orca.so or on our Twitter account, which is filled with silly marine themed puns. So on to the meat of the talk. So the few things we'll be talking about today: decentralized finance and how it's racing for scale, how the Solana blockchain aims to really get ahead in that race for scale, and exactly what that scale enables in terms of the broader blockchain and Solana ecosystem. So getting right into it, what is DeFi's race for scale? So I imagine that some of you may have heard of Bitcoin, which the founder of the white paper, Satoshi Nakamoto, described as a system for peer-to-peer electronic cash. So obviously super groundbreaking, world's first real cryptocurrency, but compared to what would come after, still fairly basic. There isn't really support for smart contracts. We'll describe what those are in a bit. The block times, so the number of minutes that pass, in this case 10, between individual block is pretty long. And transaction fees, given the current price of Bitcoin, are pretty insane. So with an average transaction price of $22.50, I'm probably not going to be paying my friend for lunch in Bitcoin, and I hope neither are you. So the next step, though, was Ethereum. So in 2015, a young genius named Vitalik Buterin really rocked the crypto world with his white paper for Ethereum, which is a blockchain which is not only a system for peer-to-peer cash, but actually has an entire built-in Turing-complete programming language called Solidity, which can be used to write these neat things called smart contracts, which are these applications that sort of reside on top of the blockchain and can be used to develop these DeFi or decentralized finance applications that allow us to make pretty complicated financial transactions without a trusted third party. So the block time also was a pretty big improvement on top of Bitcoin, with 8 seconds on average between blocks. But given the pretty insane state of the bull market, transactions on Ethereum, while originally were only a few cents, are now also about $13.50 per. So again, probably still not paying my friend for lunch with this. But it was still a huge groundbreaking event when Ethereum came to be, because it really gave birth to this entire field called DeFi, or decentralized finance, which I've been saying over and over, and you're probably like, what is that? But again, really all it is these financial applications that depend on blockchains to be the trusted intermediary, so to speak, rather than an authority such as a bank. So some of you libertarians out there may already be a fan of this. And DeFi has really taken off recently. So this chart just shows 2020, which is when I first drew it. And you can already see that it was spiked from very, very little locked in DeFi at the beginning of 2020 to almost 15 billion US dollars at the end of 2020. But where we are now is it almost has about $80 billion now in May 2021. So again, still growing compared to traditional finance, but growing at a pretty unprecedented pace. On the other hand, what's not so good, perhaps, about this spike in interest and growth in blockchains has been the spike in the time and cost of transactions on top of Ethereum. Basically, we're just overloading the network with everyone who wants to use it, which means that it's hitting a problem of scale, which is, again, very thematically appropriate for this talk. So in turn, that means that there are a lot of different solutions out there which are competing to win this race for scale, basically to be the technology that allows blockchains to scale to reach hundreds of millions of people around the world. So that includes what are known as layer 1 solutions, such as Solana, Cosmos, Polkadot, which are essentially alternative blockchains to Ethereum, as well as what are known as layer 2 solutions, which generally process some amount of transactions off of the Ethereum blockchain and then roll them back up onto Ethereum, which is that you can see, for example, what are known as ZK rollups and optimistic rollups as some of the many solutions in this space. So the exact problem of scale that underlies all of this was described by Vitalik, who is, again, the founder of Ethereum, as the scalability trilemma. And all that really means, it's a fancy word for security, scalability, and decentralization. In this triangle, you want all three because these are all key properties of a blockchain, but in reality, you can only have two, was his thesis. And at the time, that was true, at least in practice, because both Bitcoin and Ethereum optimized for security and decentralization, as opposed to scalability. And you can see that in their relatively low number of transactions per second, only about 10, whereas a modern centralized financial network such as Visa processes 65,000 transactions per second. So another reason you're not paying your friend for lunch. But at least I personally believe, and all the builders on top of Solana believe, that it is in fact possible to defeat the scalability trilemma, and Solana is the first one to have done it. So it's still a little bit, I'd say, controversial how decentralized Solana is, but I think if you look at the stats, you'll see that it's actually quite distributed. And what Solana is it's, again, a layer 1 blockchain, which was designed in 2017 by Anatoly Yakovenko, as well as a bunch of his buddies from Qualcomm and Dropbox. So some pretty intense hardware engineers who really designed Solana with performance in mind. So again, Solana is the first secure decentralized blockchain that seeks to offer performance in line of that of a single node. So again, network of tons of nodes around the world processing transactions, operating as if it was just a single server processing all those transactions. Pretty amazing. But that sounds pretty far-fetched, right? So let's talk about how that works, which brings me to part 2. So before we get into exactly how Solana is so fast, let's talk about why most decentralized blockchains are so slow. So when transactions are sent to the network, these nodes called block producers include them in blocks of transactions that are going to be recorded in the blockchain. So blocks is just sort of a name for that group, in exchange for a monetary reward. And that individual blockchain protocol specifies the amount of time that should pass between each block. And that's the term block time that I've been using throughout this presentation. But since nodes can't trust each other in a decentralized network, there are these other particular nodes called validators, which process the transactions in a proposed block and vote on whether they should be included in the blockchain, which they determine by two factors. One, whether the transaction is valid. So for example, they're not trying to count some money twice and siphon some off for themselves. And also whether that block has met the block time requirements. So what this means is that there's basically two major bottlenecks in how fast a blockchain can be. One is processing the transactions to determine whether they're valid. And the second is the classic peer-to-peer communication problem, good old network latency. And this brings us to Solana's key innovation, which is known as proof of history, which is a historical record that serves as a global clock for the system, which means that rather than having to communicate to reach consensus, nodes can simply look and validate the timestamps in the record and use this as a source of trust for how long has passed. So what exactly is proof of history from a more technical implementation side? So on the Solana network, and in proof of history, the passage of time is recorded via what's known as a verifiable delay function, which is just a fancy name for a function that takes a certain number of steps to evaluate, and in turn a certain amount of time to evaluate, but the output of which can be efficiently and publicly verified. So publicly in this case, just meaning by anyone. And the specific implementation on Solana is using the SHA-256 hash function recursively. So if it's given a random starting input, that input produces some random output, which is then used as the next input, which is used as the next output, et cetera, et cetera, et cetera. And so what this means is that hashes have to be generated in sequence by a single core because you can't predict the input. You can't predict the input from a given output. You can't predict the output from a given input for SHA-256. That means the only way to get to the certain point in this endless chain of hashes is to start from that input and just keep hashing it. And this in turn also ensures that real time passes between each hash. And so at periodic intervals, as this is happening, the count, so how many times we've hashed, and the output of that hash is recorded in a public ledger. So you can really think of this as just sort of an open record or database that anyone can see these hashes in. And a pretty cool property of SHA-256 is that it's super optimized, which is because there's been so much research into it due to the recent interest in cryptography, driven partially by cryptocurrency, which means that even a computer that's specifically designed for this purpose is really unlikely to be able to run this SHA-256 much faster than even a standard validator or node on the network. And so there's a pretty tight bound on the runtime, which means that we can trust that real time, or a given minimum amount of real time, has elapsed between any two given counts, regardless of which particular CPU you might be running on. However, though proof of history has to be generated in sequence, it can be verified in parallel. So that means a validator can quickly catch up on the ledger and validate themselves, verify rather than trust that the timestamps in the ledger are correct. And just to give a bit more of a concrete example, on a modern 4,000 core GPU, it takes just 0.25 milliseconds to verify 1 second of history. So you can see how it's easy to sort of catch up on what's happened in the ledger. So that's all kind of theoretically interesting, but how does that actually apply to the real world Solana blockchain? So on Solana, when a validator proposes or votes on a block, or that event is recorded into proof of history along with that given timestamp. And that allows other validators to check that enough block time has passed to meet that block time requirement from the ledger without needing to communicate with other nodes, as is standard on other blockchains. And as you all probably know who have worked with networks before, network latency is pretty messy. So the fact that the Solana network doesn't need it is pretty remarkable and means that it's never delayed. Regardless of any disruptions with network latency, Solana can keep on publishing blocks once every 400 milliseconds. And as a reminder, if you think about the order of seconds or even minutes that were needed with Ethereum and Bitcoin, this is pretty remarkable. Proof of history is not Solana's only innovation. The folks and the founding team have come up with a bunch of other things that makes it super performant, not only from a runtime perspective, but also from in terms of being able to parallel execute smart contracts and in terms of storage. So if you're interested in some of these other ones, these are all detailed on the Solana website. And you can also check these out to learn more about how Solana achieves 50,000 transactions per second with several hundred nodes. So that's all pretty cool, especially if you're kind of nerdy about this stuff like me. But another thing that's pretty interesting to think about is what we can actually do with this super scalable decentralized blockchain. Which brings me to this brief history. So Solana's only been live since March 2020. It's been just over a year that we've had this mainnet beta and only just a short 3+ years since Solana was originally conceived. But the Solana ecosystem has really taken off. Even since I last gave this presentation a couple of months ago, I've really had to update it because things have really gone crazy. There's tons of wallets popping up, exchanges, and a cross-chain bridge in terms of more typical DeFi stuff. But the potential for other types of applications is pretty fascinating too. So Solana smart contracts can be written in C, C++, Rust, and Move, theoretically at least, but primarily they're written in Rust. And programming on Solana is really optimized for perf, which means that it's pretty low level and requires some sort of Solana specific concepts, which might take a little while to grok at first, but do allow for writing super secure and scalable blockchains. And it's pretty fun for anyone who really enjoys diving into gnarly backend problems and writing really elegant code for that purpose. The open source Solana program library, which is from the Solana team themselves, also serves as a great reference for this. They have production ready programs, which can be used to mint and swap tokens, as well as a command line interface and JS binding. Token is just another term for a type of cryptocurrency. And Orca is actually built on top of their public token swap program, so can definitely verify that these are production ready. So if you're interested in programming on Solana, would definitely recommend checking those out. But for me on a personal level, what's even more exciting than, again, as I mentioned, what's already out there in terms of DeFi is all of the potential use cases that could be out there for this super secure, decentralized, performant public blockchain. And so that includes things like identity verification, 5G, medical records, NFTs, which have been really blowing up lately, voting, which actually there was an instance of the blockchains being used for voting a few years ago to actually verify and validate votes in, I believe, Sierra Leone. But that was really an early experiment, and we can do so much more from here. And also even say gaming. Star Atlas, for example, is a super full-scale, like modern day World of Warcraft type space game that's being built on top of Solana. I'm super excited for that. And I'm sure there'll be like way more use cases that we can't even imagine today. Things are really early stage for Solana. Again, writing smart contracts is not the easiest at the moment, but I'm really excited to see where the ecosystem goes from here. So that's all I have in terms of prepared content for today, but thanks so much. Hope it was pretty interesting, and I'll be taking a look at the questions if you have any. And again, if you're interested in writing some gnarly backend code and you might be looking to dive a little bit more into blockchains, feel free to hit us up on Twitter. We're at orca_so, and we are actually looking to hire some engineers, including a great smart contract engineer. So if writing thorny Rust code sounds fun to you, definitely reach out. Or if you just want to play around and see what a user-friendly decentralized exchange is like, check us out as well. So thank you again so much for giving me the opportunity to be a part of this, and I'll see you in the comments.
Thank you, Grace. We do have some time.